Uh, what is unit testing and why do we require it? I'll try to explain and then we'll get into code. So let me just try to annotate. So far we have been writing uh, code snippets in files. And the reason that we want to test is because we want to make sure that first thing is it uh, it satisfies all the requirements. And second thing is that it doesn't break the functionality which is already existing. So I'll come to that. So what is testing in generally? In general, is that you have a product, usually any product. For example, let us take a car, which is released from the factory, and there is a production that happens to this particular car, right? So there is an assembly line, and then it gets its full form as a car, and then it goes out. So before, let us talk about pre-production, and let us talk about post-production. And then there are also different uh, timelines, not timelines, different cycles. For example, after post-production, there is some testing and then it gets into the market. So that is like, let us think as showrooms. Okay. So what happens in pre-production is that you sort of have different components, component one, component two, component three, and so on. This could be like steering, tires, and yeah, a lot of other things, bonnets, airbag, everything. So each of this, you cannot produce this and then fit in together without testing, right? So each of this go through its own testing. Probably they're manufactured by individual uh, companies, like which are like if Maruti Suzuki is producing a car, probably somebody else is supplying all these spare parts, and then they put it together and make a car. Okay, so they have their own specifications. So those specifications are actually called as requirements, right? And they tell that okay, this is how it needs to be fit. This is the size and quality and things like that. So they produce each of these components and do testing for each of this. So this part by part testing in software is called as unit testing. So these are small units and we sort of test it. So um, coming to why we need to do this and what are the advantages is, for example, you have these components, right? So C1, C2, C3, and probably tomorrow there is some other component to the car, say C4, which is probably, say, they want to change the carburetor or something like that. So a new component is added, and then when you put so when you install this, or when you put this into production, if you have not tested this and also these things, so it will cause problems, right? It won't probably do the filtration, and it will make sounds and things like that. So this adding a new feature or a new component into the software and then testing everything in one again is called as regression testing. So regression. So this is regression testing. So we make sure in software all these components are produced in one company, say, and if somebody else is producing, for example, libraries, it's their duty to make it and test it and send it to the company. So this idea of unit testing is you can do it several ways. For example, you can write your code. Say there is something called as a, let us just for example, add.py, and we have some function called as add, which takes in two numbers and then adds and returns it. Okay, and now you can, if you want to write your own, how do you test it without knowing any frameworks or like that? First thing you would do is you would call uh, add function with different parameters like 1, 2, and say I also want to test big numbers. Sorry, say 3, 4, 5, 6, 7, 8, something like this, 93, and huge numbers. And another input will be again a huge number, say 5, 3, 4, 6, 7, 8, so on. And then you want to see whether it is calculating right. So these are like test cases, and this is second test case. And third test case, you want to um, calculate the sum of negative numbers. So -1, -2. You want to test different combinations. Now -1 and probably 2. And say again, you want to test what if user inputs a string. You can probably put like this, string and a number, which should throw an error, and we should be able to handle it. And you can have another test case where you can send both of them as strings. What happens then? Hello, and things like this. Okay, so this is the list of all the uh, varying inputs are now called as test cases. So this is just for this small function, and imagine you have like tens of files, and there are hundreds of functions put together. How do you manage this? You cannot add print statements and see yourself. So probably you'll try to automate, saying that, okay, I'll call this function add with say if conditions. Say I will take a result out of this add function, and I will check these results using if conditions. So that is how you kind of try to automate it now. So now from print, we moved on to automating it. Then you will see some patterns. For example, uh, I probably want to skip some of these test cases. I want to enhance these test cases. I want some of the, before running these test cases, I want some uh, pre-setup, and after running these test cases, I want to do some post stuff. So by doing this, now we are trying to come up with a lot of features for unit testing, that is automated testing, and then there should be some setup and closing. A good example would be, say, setting up a database and then exiting it gracefully, which is like closing the connections and so on. So all this come into your mind, and then now you are trying to automate this. So since these are like repeated patterns in software, so people have come up with various different frameworks to do this. So one such framework is called as unit tests, and we will learn about what is the syntax. But the idea is this: test cases, requirements, and then you have post and pre, and then you should have some automated way of testing it, and you should be able to skip some tests and order it, whatever. So these are the features that these frameworks provide. And also you can make test suites. Say today we have just add.py. Probably going forward, we might develop full-fledged calculator. So, so based on this, so if there are a team which is if there is a team working just on add functionality, another team is working on some other functionality. So you should have some sort of, they will write their own test cases. These guys will write their own test cases. You probably at some level, which is like when you integrate all of this, which is like post a production in car, but this is called integration in software field. So like when you integrate all the components. So during this, you might probably want to run all of these test cases of different modules, which is now becomes unit tests of each of these components. And also you can leverage the same framework to do the integration testing. So there are several, okay, this is about like requirements and these things. So coming up, talking about various levels of testing. In software testing, you might have already heard. So one is unit testing. So this happens when developers develop their own functions, and each of the functions they try to write the test cases. That is unit functions, just like components of the car. So once this is done, there is also called as something called as module testing. So now we know that what are modules? Modules are nothing but collection of different functions and classes. So that is second level of testing. And third level of testing, when all of these modules are put together and made some sort of a product. So that is called as integration testing. So these are not the only three tests. So after this, what happens is this is until this is in developers area, in the sense that development is just one component of so many processes in software industry, right? So if you want to just list down the process in software, so starting from the requirement analysis, and then there will be uh, architecture, design, and implementation. This is where uh, we develop the code. Once it is implemented, you need to have various levels of testing. So just imagine, just we can just put these two things together as one model, because this is just the developer level testing. And soon after this, there will be the actual testing starts when it goes out of the developer's box. So this is where the product level testing happens. So product level testings, they might divide it into various levels. Like they might have their own integration testing. Probably they are getting in all the components, and then they also have a wider product integration testing, and then they will have acceptance testing. So acceptance testing is nothing but this is so at this level we are verifying whether the requirements are proper from the point of view of customer. So that is why it's called as like acceptance testing. So once this is done, you can now do some more. Okay, before this, there can be other tests which are not related to just the functionality. So when we try to develop the software, we divide requirements into two parts. One is the functional requirements, which are like FR, and another is called as NFR, non-functional requirements. So what are non-functional requirements and functional requirements? Is functional requirements is obviously the functionality itself. For example, we developed add.py, and functionality is like it should take two numbers and calculate the sum of it. And if there are any invalid inputs, it should tell you that it is an invalid input, right? So that is the functionality. So what is non-functional functional requirements is you you probably have heard say security and say performance, and there are several, like at least there are like at least five. So and then you can put this non-functional requirements into this acceptance level testing. They might do performance testing, security and analysis on top of it, and so on. So after all of these things, it goes out to the production. So that is when you see your say your phones like iPhone, Android, it will get new versions, right? So this versioning has its own nomenclature. Like it has major version, and then there is minor version, and there are some bug fixes, something like this. So you will have something like say uh, 2.4.1 dot something. So this tells you that this is major version and this is minor version of that, and so on. So even in Python, it's like 3.5.1. Now it's 3.11 dot something. So 3 is major version and 11 is like minor version of that. And then if there are any bug fixes, they do it on top of it. So that is how the versioning, and that is the relationship between your uh, product release and the versioning. So how our tests are helping to do this is it helps us to, once you write test cases and the functionality is fixed, you don't have to reinvent it. Like it's already there. Imagine there are 100 people working on a software, and out of this 100 people, so if you're a manager or if you have senior teams, usually out of this 100 people, yearly there will be some, depends on the company, there will be some sort of, say, attrition. So out of 100 people, 10 people will leave and 10 people will join. So it's about 10% attrition. And on top of this, there is also organization changes. So where out of this 100 people, it will be split into different organizations, and then they will be moved to different products and so on. So you see that, and probably people go on leaves, long leaves, say sick leaves, and then there are maternity leaves, paternity leaves, and so on. So you can see that people are like changing so dynamically. We don't realize that working in a smaller team, but in a bigger picture, people are moving around. And what is happening to your code is it gets, there is a high risk of your code getting not getting enough attention to maintain it. So to maintain this code, there should be some sort of mechanism, a process level mechanism, so that it doesn't break when all of these things is happening. So people dynamics. So how do you do that is via automated testing, and you need to keep tests in such a way that it should go hand in hand with your uh, uh, the code structure. You cannot have one test file and write every unit test case in just one file. It works, of course, but you should not do that because of this dynamics. And yeah, so that is how you can break that tests into modules themselves, and test one, test two, and then you can take these tests and make this as suits. For example, in our example, add, subtract, multiply, all this can go in as, let's say, one suit, say calculator. And if tomorrow there is a new requirement saying that I also need a customer is happy, and he wants to gives new set of requirements saying that, okay, I want scientific calculator now. This is working for us, and we want new scientific calculator. So when you have the scientific calculator, your basic functionalities of calculator should not break. At the same time, you should have new features inside this. So you can make test suits saying that test suite 1, which is calculator, and test suite 2, which is a scientific calculator, and then group them together and have your own test reports. So that is about the relationship between testing, code, people, and non-functional requirements, functional requirements, and so on. So what happens generally is when we are working, we are not aware of the entire process, and small mistakes or something. Sometimes we think that this is not very important, so that will blow up in a bigger picture. So you can see that at this level, at development, the entire process, you can say the development is just one small part. Probably it's 1/10th of the entire process, right? After this, there is also even pre-sales, sales, and support, and so on. So it is just like one small part. So just keep this big picture in mind, and that is how you kind of connect the test cases. Or else what happens is, while writing test cases, we will get demotivated, because um, it's difficult to write those test cases and maintain those. For every change that happens in the production code, or the code that you are writing, you'll also need unit test cases changes. So just to give some statistics, for example, if you have written 5 lines of code, you will probably write, if it requires, if you will probably write, say, 10 lines of test cases, test code. So this is the reason that that is that demotivates most of the times. Developers will be pissed off when we ask them to write tests and keep it healthy. So let us now uh, get back to the terminal and see how it is realized. Okay. So let me take one small function, say, let us write one function, say add, and let us give some inputs, and let's add just two numbers. Okay. I'll return x plus y. This is a small function, just one line of code. And I'll take, in fact, you can put this into different file and you can work on that. So let me try to do that. I have put it here. And in tests, you can, in directory structure, you can see that I have put both of the files, add and tests.py, in the same folder. But generally, you create a separate folder for tests, and then you import these files into modules into your tests. Okay. This is just for um, demonstration. So I can say import add, and then how do we use one add? Just trying to make sure that it works. So when we do the import, you can see that the module name itself is add, and the function name is also add. The how do we use that is that, like, add dot add. Now you can see that we got an output. Okay. So when you try to program, this sort of errors will occur, and so you need and then try to solve it, or else get back to me, because these are, out of experience, I can identify them immediately, but sometimes you'll struggle for like hours together just to solve this. So and then you see that, okay, it's a small mistake. Okay, so try to do your exercises, and then, okay, now I am able to call it. How do we test is, there is I'll show you the documentation. Python unit tests. So there are several frameworks. There are two frameworks which are popular. One is called unit tests, another is called PyTest. I'll show you unit test framework first, just to understand its syntax. So unit test is a built-in library in Python. You don't have to install it. So how do you test is like this. So import unit test, because it's a module, you import that. And we have learned about object-oriented programming a little bit. So there is a class called as test case, which is inbuilt to this particular unit test. And then this is your construct, like you're writing a class for tests. So just to give you an idea how to split the code. So whenever, as I was mentioning in other class, so whenever you see the snippet of code, so what happens to our mind is that mind wants to like digest this all of this in one shot. So when you look at this code, you'll see that okay, this is a big piece of code, and I don't want to like I don't do not want to work it out and understand what is happening. So as I was mentioning, so do not get into these small chunks in the first go. So read the headlines, which is this one, and then read the sub headlines. Once you have this, you only have 4 lines to deal with. Now you understand that okay, this is test string methods. This is a class, and then there is some sort of input here. Okay, so this input is coming from, now you kind of connect this. Okay, this is the input, so that now you understand that the relationship between the test case and unit test, there is a class inside this. That is why I'm inheriting it. So in previous class we studied that class A can inherit some other class, base class. Okay, so that is what we are seeing here. And then once you see this, and you can jump into one of the functions. Usually it will be, there will be a pattern. So you can see that all the test cases is starting from test underscore. So this is how this particular class, which is we have written here. Now this particular class has become a subclass of unit test module, and then we have inherited all the functionality from this. So it looks at all functions which are starting with test underscore, and it sort of makes a list of test cases. So these are the test cases. So this is, in this particular case, they are trying to um, see if this string is um, converted to capital. So this is a string, and then there is a function which does the converts from lowercase to uppercase, and then they are trying to assert it. Assertion is nothing but it's like verification. It's similar to like writing if condition. If A is equal to B, then like print okay, something like that. So assertion is like that. So the difference between your if conditions and assertion is that it has additional functionality. For example, if this fails, it will stop the execution. So now we have now we are trying to learn a pattern where you're sometimes what happens is when this assertion fails, there will be a stack trace or trace back which is printed, and it doesn't execute any of the test cases later on. So when you're working in a company or in a team, so the first thought that comes to your mind is, okay, this doesn't belong to me. So I will somehow put, say, exceptions here, like try and exception block, and then handle this because I am not the owner of this particular code, and I want other test cases which I have written that needs to be executed. So never do this never use or try to escape these particular assertions which are in the test cases. You need to handle the exceptions in the code that you have written, but not in the in the test. So assertion are by design it is expected to stop your list of test cases to like halt, so that you fix it and make sure that it doesn't have any side effects on other test cases. Say for example, in our own example here, for example, probably I have written add.py. So you make a change here. Say now we want to add three numbers x, y, z, and you forgot to add it here. Okay. So you're just returning this. and probably you have written print statements and uh, whatnot, and then you have tested z is equal to 0 for, and then you think that okay, this is working fine. So this is just one line, it's an obvious error, but it happens in, like, when you have big code, uh, the errors are not obvious, and for some uh, inputs your code works, and then you think that okay, this test is working, and then you sort of move on and ignore that, and then go away. So never do that. Make sure that the existing test cases are always working. Okay. So that is about, and yeah. So how do we write test case here? By, we have learned the syntax now. So let us try to do it here. I'll clear the drawings. So let me try to, you don't have to remember anything. In fact, nowadays, I'll show you in coming weeks. So you can also have a co-pilot, or you can ask ChatGPT saying that, okay, I have this function, this takes this inputs, provide me the test cases. It will write its own test cases, and it works. And but the thing is, you cannot copy everything that it gets generated, because you are the ones which who knows the requirements, right? So it sometimes so happens that you plug in some code from, say, it is as good as taking from Stack Overflow, which we do. And when you put the code, if you're not aware of requirements very well, like, you are creating additional problems for yourself on the entire product. So be aware of these tools, that you take only exactly what you need. Okay. But the idea is, do not remember the syntax, just feel free to take the, so I'll take this. Excuse me. I have imported the model which I need to test. The order doesn't matter here. You can import it anyways. So I'll change this, say, test. Calculate. This you can write anything. And what you do here is, you sort of write test and underscore. So this is how you sort of uh, tell the framework that this is a test case. And since this is a class, you should also write self. You can write any variable, but self is, by convention, it is the object itself. And probably you don't require any arguments, and then you call add, and then you sort of give some numbers. So just by doing this, let us see what happens. So nothing happens here, because we are not calling anything, we are not invoking. So this is just a normal class and normal function which is defined inside. So how do we run the test case? Okay. So let us look at the documents. There is a way. So one is, you take this. So we have learned this already. So execute this particular function only when you are running with this file. Okay. Let us execute and see what is happening. So you can see that this this ran, but we got some error. So what is this error? This was uh, the same error that we got when we started with writing here, writing the test, like we were verifying, right? So this is a module, and I'm trying to call the module itself. So now in order to call this, I do this. You can see that it says that test cases are okay. I ran one test case in 0 seconds, and it is okay. So this is not, I've called the function, yes. This is not the test case itself. Although you are trying to use unit test, and then you are trying to use this convention and calling the function, this is not validation at all, because we are not validating the output. So how do you validate? Generally, you can take a variable, say result, or you can call the function directly. And this is the one which you need to validate, right? So whether this result is is equal to, uh, in this case, it needs to be 7. So this is how you sort of validate. But there is a you cannot do this. This is not right, right? So programmatical. So there are inbuilt functions which does this. So either you can write your own if functions, but uh, that won't get into the reports. Although it works, that is not how it is to be done. So you can see that once I typed in self dot, you can see that there are several functions it is listing. So this is the feature from IDE. So you don't have to remember. So now I want to just use whether this is equal to 7. So probably this is the one, assert is equal to this. Then result, and then that number, which is 7. Now you can see that again it ran successfully, and this is how you need to assert. Let us try to give some other number, and let us try to. So this is how it is validating and telling you that. So I was talking just a while ago, saying that mm, even if you have a lot of test cases, the first error it will throw this. This is a traceback, and the reason that it throws is by design. So do not try to sort of imagine that you are trying to uh, do this. If you try to do that, then it's like you are trying to make some like adjustments, and your uh, product will break, right? So this is a test case. Let us add one more test case. I'll take all of this. So let me call this as add, say ints, and I'll do some negative numbers. So the requirement is take two numbers and add it, right? So if I pass, this is like add negative numbers. So I'll just give this, and I'll keep result as same thing just to show you what happens. You can see that I ran two tests, and this one got failed, and your test file or the test execution is like halted. So you'll get this, and you'll get the failures, and also if it's in pipeline, it will break that pipeline, and it will also return the exit status to non um, non-zero. So when you have shell non-zero exit status, usually the DevOps team will check the exit status of that process, and if it fails, they will break that pipeline. So okay, so now we are trying to test negative numbers. So now I made some changes here and did this. So let us okay, this works. So let us look at how the code changes according to our test cases. Just imagine now we know that okay, this is a function, and which takes in two numbers and adds it. Now imagine that somebody else is doing your test cases, and you are the one who is developing. In fact, both of them are developers' responsibility. It's not like testing team is doing this. It is you who is doing this because you are deploying or delivering this code. You need to do this. In fact, the testing team will have their own different set of test cases, and they will have different suits. So let us just take the same this one, and I'm going to copy and just modify it. Add string. Let's see what happens. Add string and int. So my expectation is here, say hi for, okay, this should not be the requirement, but this is a test case. And let us try to, so we got previous with test cases, 2 test cases are uh, successfully executed, and we got okay. Now let us look at this. Now you can see that this is a invalid operation. So in one of the classes where we read about inputs, so we try to uh, process that input. Inputs are generally stored as strings, and then we sort of typecast it into integers, right? So we are trying to add a string and a number. So which is obviously not right. So it says that I can only concatenate strings, not the integer on string. But I don't want concatenation. I want some sort of error. So let me redefine this code. Now, because of this test case, there is a change in, which is a valid test case, and there is a change in code. So how does the code change like this? So I may change it like this. I can, if x is of type, I can do that. There is an inbuilt function called as is instance, which is nothing but we are checking the type of that particular. It is similar to type keyword that we have been using so far. Is instance x int and is instance y also should be integer. Okay. Only then do this, or I can simply either I can do this or else I can return from here as well. But if it is try to initialize this, or else what happens is sometimes it goes this result won't be uh, initialized, and we're trying to return something which is not initialized. So this make this a practice. So if you have some variables which are defined inside if else conditions, make sure that if you're returning that particular variable, make sure that it is initialized already, or else it will you'll get errors. So now let us see what happens. Okay, so that's fine because I'm not calling any add here. So I'll again do this. Now you can see that I got that error for this particular input. I have written code, but now I also need to change the expectation here. The expectation should be, this should be result. This should be actually is equal to none, because so probably you can in real world example, probably this will be some sort of error saying that invalid output or something like that. Invalid input, sorry, input. And in fact, you can put the same string here, invalid input. So that is how your, these are the from requirements we are listing out. Coding is actually the one of the last things or one of the easiest things to do. First thing is you need to understand the requirements that, okay, this is the function. So you can see that. So what is the line or number of lines of code that we have here? So 1, 2, 3, 4, 5. Okay, you can see the line numbers as well. But you can see that this has grown like this. So even if you calculate from 5 to 15, it is 10 lines of code. In fact, there are a lot of test cases we haven't written. So this is one of the reasons that it sort of demotivates or pisses off the developers that I need to maintain this unit test cases. So there will be always arguments in teams that, okay, this is written by somebody else, and this is, and so what happens is finally they decide that, okay, let us refactor the code, and that will take a lot of time to, months to get things done. Okay, so that is the importance of unit test case, and this is how you sort of write it. And there will be some places where you sort of want to do some sort of action before and after every test case. Okay, so let us try to understand what are they in terms of test cases. So let me open one of the documents. So they're called setup and tearing down. So I'll give you the syntax for that. I'm copying it from internet. So these functions are inbuilt to the test case, this class which we have inherited from unit test. So these are functions which is since it's already there, and then we are trying to overwrite it. So let us see how it behaves. So, right, say print init this, and I will do the same thing here. And this. So let us now run the same test case. So we just added 4 lines of code, which is setup and tear up. So just while reading this, it's just 2 lines, setup and tear up, and other things are like details inside that. So let me clear this. We run it again. You can see that there are init phase, tear down phase printed thrice. So for every test case, we do something pre and post. So let me just print the result so that we come to know that how it is embedded. So that we understand that it is post. We can see that in its phase, and we are printing something, which means that this test case is executed. And then again, same thing, init phase, something, that result, and then tear down phase. So for before something and after something. So it's like before the test case, you do something, and after the test case, you do something. So this is called as setup and tear down. So this is, there will be some places where you want to actually do it just once per this class. So that is called as, this is slightly different from this setup. So it has, for example, I do not say you are initializing database before doing this, and your all the inputs are taken not from here. This, I'm just typing it right, so I can actually take from a database. So I can, maybe I have a loop where I input a lot of inputs into this, and the inputs are coming from the database. Just imagine that. So either I can write connect to database in every test case, or I can do it simply once here. I can do it. But opening a connection for every test case is not an efficient way. So I probably want opening the database or connecting the database just once uh, during the course of this particular uh, test suite or test file. So in such cases, it's it happens at the class level. So those functions are called class functions. So syntax is like this. So let me remove this so that you can see that there is CLS. There is CLS. This is in fact the object itself. But you can also see that in line number 10 and line number 6, there is some sort of a new syntax that we are trying to see, which are called as decorators. We'll come to that later. So decorators are nothing but some functions which take this function itself as parameter and do something. You can think like, for example, when we try to give a gift to friend, right? We take, say, I have purchased a pen, and then I sort of put a wrapper around it and gift it to him. So the functionality of the pen doesn't change, but since we are wrapping it, the functionality or you know the occasion changes. So it's like it's his birthday or something like that. So it has a wrapper on top of it, and the functionality is still the same thing, but the view changes. So that's just the in other languages it's called as wrapper functions. And in terms of design patterns, they are called as adapters. But yeah, in Python, these functions are called as decorators. So various names, but it's the same thing. You are taking some functionality and then wrapping inside that. Yeah, just keep that in mind. We'll cover that later. But what happens when you add this particular uh, um, decorator is that it makes this class of makes a function as like a global function. Generally, well, so far we have studied that in an object, when you have a function, you need to instantiate that object and then use dot and then access that, right? But when you use this particular class method as a decorator, what happens is you don't need to create an object to access that particular class. So this becomes some sort of static functions. So in C++ and Java, it's like static function. So you can also access those functions outside without instantiating the object. So that is what it is doing. So just for our use, um, since we are um, setting up database once for all the test cases, so let us look at this output. So I have executed that, and I have print here inside this setup class and teardown class. You can see that setup class is happening at the beginning of the test cases, and each of these test cases are running with pre and post conditions, and then finally it tests on the class. So yeah, that is about how you make use of unit test. There is also another framework called as PyTest. Yeah, so some companies use that, some people use that. It's similar idea. So there is, you make that as test cases and then you sort of generate the reports. Okay. So in fact, there are various command line options uh, telling it to generate in different formats. For example, I can generate HTML format, JSON format results, and then probably keep it as a evidence for testing, and then upload it somewhere for the next process. That we keep all the reports for all the levels of testing, so that if there is any problem in the production, we sort of trace back where it is missed. So yeah, so reports are important. You can also generate reports. You can read it later. But this is how the unit test cases help us to test our functionality, and you can leverage this unit test to write integration test cases as well, because we are just simply calling modules, right? You can import as many modules you can want, and now we are putting all the modules together. So integrate all these functions in a flow, and you can actually test the flow itself. So using unit test framework, you can actually write integration tests as well. But the general idea of unit test is test function by function, and make sure that your requirements while writing this, you just know the requirements. When you have this, you are validating it, and we are trying to make exactly what customer requires. So unless you have this, so when you say this, it looks good, but if I add more test cases which are slightly different, then this test cases, your code will start breaking. So we just saw an example. So that is why we added this particular, when we added this particular test case, the code broke, and we fixed the code. And in fact, as you write test cases, probably your code will start growing. Say, yeah, unlike that. So maybe I'll add. a very huge number, which is probably 100 characters, like 100 digits. So whether Python supports it, or if it does support, whether the sum is correct, because I'm trying to add 200 digits. So finally, it may end up in something like 120 digits or something like that. So on. So whether memory supports that, whether Python supports that. So if Python doesn't support, so then what I need to do? Probably I need to keep each of these numbers in a list or something like that, and then there's a good exercise in C++ where you sort of create linked list for these numbers and try to add huge numbers. So similarly, maybe you will have to write. So when you start writing that test case and add this code will probably increase it to probably 20 or 30 lines more, because there is no inbuilt functionality to add huge numbers. So yeah, so that is how the relationship goes in hand to hand. The only thing is it takes first time it takes a lot of your energy and patience to write this, and once you write this you can sleep peacefully. So that is the advantage that you get writing test cases. Like you won't have nightmares. So you imagine that you you, you have deployed your code, and something is breaking from support team, and they're like calling you, and then you can simply say that, okay, this requirement is already done, that there should be some input problems or something like that, so you can sleep peacefully. And that is the greatest advantage you get. So if you do not have this, then when there is a pressure, you cannot probably write and modify the code, because your manager is asking what is the root cause. I want every 2 hours uh, a report. You are trying to look at your code. Probably this is not your code at all. Somebody else has written, and there is no test cases, and you will be like lost. You'll lose your sleep. Okay. So that is the like impact of not writing unit test cases, and you should be aware of these things. So since it is not motivating to write unit tests, so I'm just giving you points where why you should write unit test case. Okay, that